In section 3, we are going to look at other pollutants that enter the water. So we're going to begin by recalling the definition of water pollution. It's anything that leads to biological, chemical, or physical degradation. Thermal pollution occurs when we add temperature to the water. That causes it to hold less dissolved oxygen, leading to all of the problems that we discussed in the previous sections. It leads to growth of undesirable organisms and changes the species composition of the body of water. Sources: industrial discharges and power plants. Here is a picture of Charleston, West Virginia. Remember, in Charleston, the power plant puts water back into the river there. This is Mount Storm, West Virginia. Here, a power plant is putting so much thermal pollution that it's basically always foggy. This is the body of water near Mount Storm, where the superheated water is put into, and you can see all the algae growing on the rocks here. We also have point source pollution. It's a discrete, confined, identifiable emission source. Remember, point sources, think about, is there a pipe? You can see a pipe in each picture down here at the bottom. Right. Possible point sources are landfills, wastewater treatment plants, industry, power plants, stormwater runoff. It even says it here. Think pipes. The fix to point source pollution is to identify the source, treat it on site, and then also think about prevention via laws and limits. Non-point source pollution. It's diffuse, it's intermittent, it's hard to identify the emission source, and it also has a cumulative effect. Source: runoff, urban and agricultural, pesticide applications, mining and forestry. The fix primarily is education and best management practices. Here we have pictures of non-point source pollution. A parking lot. This is debris and runoff into a stream. This stream has been dyed yellow from the pollution that has gotten into it. Maybe not dyed, turned yellow, might be a better way of saying that. Groundwater pollution can be point source or non-point source. So common sources of groundwater pollution and contamination: leakage from storage tanks and pipes, leakage from waste disposal sites such as landfills, seepage from septic systems and cesspools, accidental spills and seepage, train or truck accidents, for example. Those are our top 4 sources. After that, we have agricultural activities like feedlots, leaching and seepage from mine spoil piles and tailings, seepage from spray integration. I cannot talk today, dreadfully sorry. Spray irrigation. Right. Some of these are point source, some of them are not. Here we have underground storage tank leakage. This would be, for example, a gas station. This would be the gas storage tank. You can't see that it is happening, but because it's leaking, it diffuses downward into the water table and therefore contaminates the groundwater. This is a picture of an underground storage tank being removed. Look at how leaky it is. These caps at a gas station cover or access the underground storage tanks. Here's one being put in. See the liner around the cavity where this tank is being put in to try to control if there is seepage. Last chapter we covered landfill leachate leaks. Here we are again. Here is our landfill. The leachate comes out and can get down into the groundwater. Think about a septic system. These are rural wastewater disposal systems. Here you have your house. This is an overview, a top view, so this is the roof. You have a sewer line that leads out to a buried septic tank, and from there, water comes out and goes into a drain field. Both gray and black water go into the septic tank. After being in the septic tank, primarily it's gray water that comes out. Right. The solids drop to the bottom because then microbes break it down, and then the liquids flow to the drain field and percolate out through the soil and are decomposed by microbes there. Here is a septic tank being installed. This is just something to think about. You have a house with your septic tank in the drain field. The house also has a well. Well, the drain field can drain into the groundwater. So if the groundwater is flowing on the screen from left to right, then it is upstream from the well, which means all of the stuff that went into your septic tank and drained out is potentially getting into your groundwater and coming up to your drinking water. So, groundwater pollution can occur when Clorox and other toxins kill tank microbes. So if there's no tank microbes, that means that's not getting taken care of. The tank backs up, or right, the effluent, the liquids, are not thoroughly decomposed before it enters the groundwater. That depends on time. Or if the water table rises. So here's something to think about. This house has an active well and a septic system which goes down. The next house also has an active well with a septic system. If the effluent is not being thoroughly processed from this septic system before it hits the water table, that means those chemicals are going into the drinking water of the next house. This is a train accident leading to a water contamination problem. Obviously a truck accident, trying to contain something here, I'm not sure what. Same thing here. Isn't this a lovely train car? There is legislation on these train cars trying to keep them from, if there is an accident, spilling, but doesn't always work. Here we have seepage from a commercial agricultural feed operation. So where does all the output from our pigs, if you will, go? You can see where the cow output is going, directly into this stream. This is an overview of a feedlot, and this is an irrigation ditch from a feedlot. Here are carcasses. Where does the decomposing materials from this go? Or the hen house. These might be turkeys. Regardless. Think about mines. Here we have a radioactive tailings pile near the Colorado River and a wetlands preserve. And 1 mile downstream is Moab, Utah. Here is another mine. This is the sludge from the mine being contained. Isn't sludge lovely? We have irrigation seepage. So yes, it's water, but are they putting fertilizers in the water? Are they putting pesticides in the water? What exactly is coming out of these pipes? Here is a different way we could possibly irrigate. These are irrigating each little tree individually. All these little white hoses. These are tomato plant, irrigation, and it just seeps out into the ground near the plant. This is a plain putting on pesticides. We've talked about this a little bit, the fact that the septic systems could get into the groundwater. Also seepage from a landfill, or possibly the output from a industry could get into the groundwater, right? Drilling can cause substances to enter the groundwater. So the Marcellus Shale, remember, is in West Virginia as well as the surrounding region. And they're currently looking at doing fracking in order to harvest primarily natural gas from that shale formation. So here is a picture of where the Marcellus Shale is. There are a couple videos at the top. I will put those into the unit down below, like I have the last couple of units. Here is Shepherdstown, West Virginia, and Morgan Grove Park for reference. The Town Run is a stream which runs through Shepherdstown down to the Potomac. It actually runs through campus. Let's see, where is the Town Run? It enters the Potomac right over here, kind of below the bridge. Where the actual path is a little hard for me to pick out, but it originates by a spring in Morgan's Grove Park, which is why this is being shown. The riparian zone in Morgan's Grove. This is where they're trying to prevent pollution from entering the stream by planting plants around the stream bed. Here's a picture of it in Morgan's Grove Park.